Deadpool 2 features a whole load of new characters, including this one.
Domino, I'm lucky.
Luck isn't a superpower.
And certainly not very cinematic.
Yes, it is.
Let's meet in the middle and say no, it isn't.
Now, I have to disagree with Deadpool on at least one point, because that did look pretty damn cinematic. But he might have a point about luck not being a superpower, because it could, in fact, just be down to some physics. To illustrate this, we're going to play a game. Yes, you do need to get involved with this. All you need is a coin. Make sure it's a coin that has both a head and a tail. No two-facing with double-headed coins here. That's not allowed. That's actually cheating. What I need you to do is just pick either heads or tails on your coin. Simple as that. Heads, we'll call that 1, tails, 0, okay? I'm gonna do the same, and when we reveal our answers, we'll find out who wins the game. Basically, if they're the same answer that both I and you have, then I win. And that means you have to send me your coin. Right, this is a legally binding game that we're playing right here. So the address is in the description. You do have to send it over, otherwise we'll send legal people involved. On the other hand, if the outcomes are different, then I lose, you win, and I send you this coin or its value. Just write your bank details in the comments and I'll get my Nigerian prince friend. He'll wire the money out. It's all simple. That's all that's involved. Are you ready? Okay, 3, 2, 1. I'm actually going to flip mine. And tails. Put your answer up there. We'll work out how much I've won and how much you have all won. Now, for this particular game, it's actually very easy to work out what the chance of winning is. It's just 50%. Well, what would it mean for you to be lucky at this game? Well, I guess it would mean that you'd win way more times than you'd expect purely by chance, taking into account the sort of statistical errors that I've talked about before on these sorts of games or experiments. But is there a way of doing that? Well, let's change the game ever so slightly. Instead of using coins to represent a 1 or a 0, we'll instead use random photons that have been given to us by a fair referee, okay? We'll send them through a polarizing filter, which will work out whether they're oriented like that way or essentially that way, and then use a single photon detector to see if you get a photon, which we'll call 1, or heads, and if you don't, 0 or tails. It's essentially exactly the same as the game we just played with the coins. So still, the chance of winning is only 50%. But now I'm going to do something slightly different. Whilst you continue playing that way, I'm going to start playing a slightly different way, utilizing quantum mechanics. Essentially, if I just put another polarizing filter in the setup, I could then change the angles and see if I can get a better result out. You see, quantum mechanics is a probabilistic theory. It does use probability to work out the likelihood of outcomes. But there are some slight differences in the way probability works in quantum mechanics compared to normal probability theory. Firstly, you probably know that in quantum mechanics, we can describe a state as not just being a 1 or a 0, but it can be a superposition of the two. Essentially, both states at once, which we normally write something like this. And those coefficients in front are linked to the probability of getting that outcome. In fact, the probability is just the square of that number. Now, when you have a superposition of states, when you actually make a measurement, then the state actually collapses down into the outcome. So you'll pick one of those states. It's no longer in that superposition. But as long as it's in the superposed state, then you can get different outcomes in terms of some probability measurements. So that's the first way quantum is different. The second way is that we can have entanglement of particles. This basically is a link between the two photons such that the outcome of one of them will affect the outcome of the other. Or spooky action at a distance, as it's often referred to. We know this actually occurs because we've done experiments that prove this actually happens. Okay, back to our game. Let's assume that the referee is completely fair. He or she has given us photons with an absolutely random chance of being in any sort of position. However, if they are perfectly entangled, I can actually utilize a strategy to win 100% of the time. By rotating the polarization filter that I've added to the setup just by 45 degrees, gives me a 100% chance of winning. Sorry, you're gonna have to send me your money. This has actually been shown experimentally as well. Well, they got a 94% chance of winning rather than 100, but you know, it's really difficult to make a whole load of absolutely perfectly entangled photons. And this isn't the only game that you can play where you can up your chances of winning, essentially coming off like you're lucky. Quantum game theory is an actual thing where you can find quantum strategies of trying to win games. Now, often in quantum game theory, it is entangled particles that you need to use to actually get these outcomes. But the really weird thing is with the game that we've been playing is they've shown that when you start to reduce the level of entanglement all the way down to 0, it doesn't actually take you back to 50%. You still end up winning more times than you should, classically. So from the point of view of somebody that doesn't understand quantum mechanics, you're just incredibly lucky. So you know what? I actually agree with Deadpool. Domino, she doesn't have a superpower. She's just using quantum mechanics. Thanks so much for watching this video. Please don't write any bank details or addresses down there. That was just a joke, all right? But it would be great if you could give this video a like and tell me what you think about quantum game theory and whether you think Domino is actually utilizing that in the movie to be lucky.